Okay, let's continue. This is our third art session, and we'll start doing something that's cooler than we did in previous art sessions. But without the foundation we built in previous art sessions, we just cannot advance, right? So bear with me. You will soon see the power of R. Okay, so in previous class, we know that we can create character and numeric vectors using the concatenation function C and give those vectors names. So let's start doing creating some vectors. Hopefully you can see these, see my typing rather clearly. So students, let's create a first vector named students, and let's make up some names. C, um, starting with Andrew, then Bree, Kathy, Derek, Emily. So it's five. So I give a comma and then I hit enter, not control enter, but enter. So to start a new line, this is only to increase readability, right? So that we don't have a super long line, we can have two short lines. Um, that that simply is clearer for us and for readers to read. So Frank will continue. George, GH will be Helen, my favorite female name, Helen. Ivan and Jennifer. Okay, so this is our first vector, students, and it has 10 string values, right? So we can hit Control Enter, and then we have a student vector stored in memory. Let's continue. Let's create a second vector. Let's call it age. So let's just give this vector some numeric values. It's 20, 25, 19, 18, another 18, 22. So again, I start a new line by hitting enter once to increase readability. So 25, another 25 perhaps, and 23, 25. Okay, so this is 10. Yeah, okay, so control enter. You see we have a second vector created and stored in R's memory. Finally, let's create a GPA vector. So C, okay, so 3.4, 3.4, 2.AA, 3.47, 2.87, 2.91. Right, that's 5. So, well, when you want to switch to a new line, you should always finish the previous line with the comma. Otherwise, R will yell at you. So 91, 2.96, 2.14, 3.75, 3.48, and 3.7. Okay. Well, I just made up these numbers, so they don't really mean anything, but it just look like GPA scores. Okay, so hit enter, control enter. Now we have the third vectors. We can print them in R and have a look at them. Age, semicolon, GPA. Okay, so here we have the three vectors, right? The first one is student, second one is age, third one is GPA. All of them have 10 vectors, 10 elements. Okay, so you see here, R always prints the elements of a vector as rows, right? Or I should say, R always print elements of individual vectors, right? This is the vector of students. They always print elements of individual vectors as rows, right? There's one row, it continues. There's a second row, a third row. So this gives the impression that vectors represent rows of elements. This is rather unfortunate because R actually stores vectors as columns. Um, we can find out actually by using a new function here that's called transposition. So transposition, right? Transposition. So this is the name of the function. So I'll give it a comment so that R will actually not run this comment. Um, what transposition does? So this is the transposition function T, and then parentheses. What transposition does is once you put a vector inside the parentheses, it would turn the vector, well, if the vector is a row, then it would turn the row to a column. Well, if the vector starts as a column, then after transposition, you'll become a row. So in other words, if a vector is a row to begin with, then it should become a column after being transposed. Conversely, if the vector starts as a column, then it should become a row after transposition. Okay, so now we can find out how R actually stores vectors. So we can transpose any of the three vectors. So for example, we can transpose age vector. So simply do T parentheses and age and hit Control Enter. You see here after transposition, right? So after age is being transposed, R gives us a row. That suggests originally R stores age as a column because transposition converts columns to rows. Now the outcome is a row that suggests the input is a column, right? To find out, we can transpose the transposed age vector, right? So age. So this is the first transposition, and then we transpose that transposition, yeah? Control Enter, now we see a column. So this is actually how R stores vectors in its memory as columns. Now R print out vectors as rows, my guess is to save space, right? So if it prints out all vectors like this, it's going to be lots of space. The space is not wisely used. But anyway, this is important because understanding that vectors are actually columns of elements will help us understand the main topic of this lecture, which is data frame. But before I actually go to data frame, let me quickly comment on the numbers or the indices in these square brackets. So in a square bracket, the first number indicates row. So this is row 1, the first row, the second row, the third row. Now, the second number in a square bracket indicates column. So this is column 1, and we only have one column, right? So you see here, we don't have anything after the comma, and that's because this gives us the entire first row. This gives us the entire second row. Similarly, we don't have any number in the row position, right? There should be a number before the comma, but we don't. So that indicates the entire first column, right? We'll see more of this in a minute. Okay, so as we said, the main topic today is a data frame. Data frame is one of the most important concepts in R. Simply put, data frame is R's way of representing data sets. And there are many technical definitions of data frame, but for the purpose of this class, let's just define a typical data frame as an object that consists of multiple column vectors horizontally combined. So let's see what that means. Okay, so well, let me just say, I'll give it a comment. Data frame is an object that consists of multiple column vectors horizontally combined. What does it mean? So let's start with an example. In R, to create data frame, we use the data frame function, data frame. Okay, so this is this function with a period here. So what goes into the parentheses will be all the vectors. So we can combine vectors into a data frame. So that's why we created all these three vectors to begin with, right? So I want students to be in the data frame. I want GPA, age to be in the data frame, and GPA in the data frame too. And that's it. Let's hit enter. This is our data frame, or data set, if you like to call it that way. That's also fine. So we have three vectors. Now you see R now represents vectors or variables as columns. So these are multiple column vectors, right? Column vectors horizontally combined, right? They're right next to each other, right? So here you have 10 observations or 10 rows and 3 columns. So each row represents one observation. This is the observation about Andrew. This is the observation about Derek. Then this is the observation about Ivan. And then each observation has 3 values on 3, well, yeah, each observation has values on 3 variables. First variable is student or name. The second variable is age. The third variable is GPA. Okay. All right. So to facilitate our subsequent operations, let's actually give our data frame a name. So let's just call it df1. So the first data frame. Okay. Let's run it again. So df1, that's our data frame, example data sets. So importantly, right, as I said, each data frame has row components. They have rows and they have columns, and each value is in a cell. Okay, so if in a data set, each variable, student, this is one variable. If each variable has its own column, and if each observation has its own row, and each value has its own cell, then we'll say this data frame or this data set is tidy. The tidy data is the best kind of data because it's very easy to analyze. You can imagine that sometimes data are messy because multiple values are contained in one cell, and that's not good. So our goal is to use R and other statistical packages to create or to turn messy data into tidy data, so that that will give us much easier time to analyze those data. Okay. After you created a data frame, well, this is a data frame or data set that we can start analyzing, right? So, for example, what's the average age? What's the average GPA? Is there any correlation between age and GPA, etc., right? Or we have obviously males and females in our sample. Then you can ask, well, do females have higher GPAs than males, right? So with data frame, we can start to analyze our sample and answer questions. But before we start analyzing our data sets, the first step in any kind of data related practice is actually to know your data. Okay, so that's a very first important step, because without knowing your data, very likely you will make mistakes when analyzing your data. So the first step, at least in R, is actually to ask R, wait, so is this actually a data frame, right? Because you created something that you think is a data frame and you load it to R as something that you think is a data frame, but it might not be a data frame. And if you perform operations on an object that you think is data frame, but it's actually not a data frame, then you're making all kinds of mistakes, right? So first of all, let's make sure that R recognizes df1 as a data frame. So our class function is now used again. R tells us that you're right, it is data frame. Now you can also test, right? So is data frame, right? So now we're saying, well, hey, is df1 a data frame? True, it is a data frame. Okay, so we saw these two functions before, so they're not entirely new. Something new about data frame is we can ask about the structure. Right? We can ask the structure of a data frame. To do that, we can use the function str, well, the first three letters of the word structure, and then we put our target data frame inside the parentheses. So this is going to be df1. Yeah. So str parentheses df1, and we hit Control Enter. See here, now R tells us that first of all it is data frame, and this data frame has 10 observations or sample size of 10 on 3 variables. The first variable is students, and the type is vector. And we'll talk about what this means in later R sessions, but don't worry about it right now. Age is a numeric vector, right? We saw this before. GPA is also a numeric vector, right? So see, structure, this command gives us a very quick overview of what your data frame or what your data set actually is like. So after that, you can say, okay, so now we have confirmed that our object is data frame, and now we have a very general overview of the structure of data frame. Now you want to say, well, let me have a look of some of the rows and some of the columns. How can we do that? Well, we can then use the head function. So the head function would give you, by default, the first 6 rows. So we put df1 in the parentheses and hit Control Enter. 1, 2, 3, 4, 5, 6, right? Exactly the first 6 rows with the variable names on top. Okay, we call this line the header of a data frame or data set. But anyway, the first 6. But you said, well, hey, I don't want that many. Then you can say, well, you can specify exactly how many rows you want. df1, a comma. You say, well, I don't want 6. I want 3 is enough. Okay, so you say, well, I want the first 3 rows of my data set df1. You can do that. Now you have the first 3 rows. Now sometimes for some reason you want to see the last rows, the last several rows. You might have guessed, then the function will be tail. Okay, so tail df1. So again, the default is the last 6 rows, right? 1, 2, 3, 4, 5, 6. But again, you can say, well, I don't want 6, I want 7. Yeah, that's okay. That will give you the last 7 rows. Okay. Sometimes you're not just happy enough with viewing certain rows and certain, select rows. You can say, well, I want to see or view the entire data set. That's also possible. Just use this command, uppercase V, and then IEW view, right? So you must be uppercase. So view df1, and then Control Enter. Now a new tab will show up here, and this will give you the entire data set. Okay, so this is possible when data sets are small, as in our case. But once you have data sets in gigabytes, then this might take a long time to load, right? Then it might actually make more sense to view the first and last few rows, just to make sure that they're looking exactly like what you want them to look like. Okay. Okay. So far we talked about how R represents vectors, and then we talked about a new concept that's data frame, essentially as it's how R represents data sets, and we learn about several commands that will allow us to have some preview of our data frames, um, including head, tail, and view. So in the next brief video, um, we'll be talking about how to subset data sets. Okay, see you very soon in the next video.